Pharmacogenomics. This concept may be hard to say, but is not very hard to understand. Pharmacogenomics is what the name says it is. Pharma is having to do with drugs and medications, and geno has to do with genes and genetics. The co means and. Pharmacogenomics is the combination of genetics and medication. In pharmacogenomics, researchers look at a person's genetic sequence to see what medications will work best for that person and at what dosages. Every person has a unique genetic sequence, and that means every person processes medications differently. Because of this, if a person is given the wrong medication, it could have serious medical consequences. One advantage to the potential for pharmacogenomics, as found on the NCIB website, is that this technology can keep people from having negative side effects from their medications. This means that more people can get out of the hospital sooner, which can in turn create more beds for new patients. This means that hospitals will not only be able to treat patients more accurately and effectively, but they will also be able to treat more patients in less time. Another positive of pharmacogenomics is the opportunity for drug developers to develop more effective drugs faster because they can test the drugs on people who are likely to benefit from the drugs. This also allows companies to develop drugs for people with a certain type of genetic sequence. This not only allows companies to develop more drugs faster, but also to develop more effective drugs. This was also found on the NCIB website. The last benefit to pharmacogenomics research is the creation of more jobs. Pharmacogenomics requires people to analyze the genetic sequence of any people who could potentially receive the drug in testing or for treatment. This means that there needs to be hospital and drug developer staff that can analyze patient and test subject genetic sequences. These are jobs that have not existed in any significant sense, so many more jobs will be created. This is, again, according to the NCIB website. A negative to pharmacogenomics is an increase in inequality in the drug industry. Currently, the development of drugs greatly favors developed nations. 90% of drugs developed are developed for rich or developed nations, meaning only 10% of drugs made today are for undeveloped nations. With pharmacogenetics, a large concern is that the drugs that are made using this new method will be too expensive for undeveloped countries. This will result in over 90% of drugs being created for rich and developed countries. Another negative for pharmacogenomics is how insurance companies will handle more specialized drugs. It is highly likely that insurance companies will raise rates for customers who are prescribed to these specialized drugs. Another possibility is that insurance companies will not cover the cost of these specialized drugs at all, or if they do, the coverage will be very minimal. These drugs will likely be very expensive, and any of the situations with the insurance companies could seriously inconvenience or even harm potential patients and make them unable to pay for the drugs they need. Both of the negatives were found on the NIH and NCIB websites. Now for my opinion. The development of pharmacogenetics itself is only accompanied by positives, so I support the development of this method in every situation. I am in agreement with the NIH and the NCIB that the future of pharmacogenetics is very promising. As stated earlier, there is a possibility for more effective hospital treatment, more effective drugs, and more potential jobs. The only clear negatives to pharmacogenetics is the distribution of the newly developed drugs, and not the creation and usage of the drugs. The problems with the distribution of the drugs that were made using pharmacogenomics can be solved over time. The benefits are overwhelming, and that is the final opinion of me and the NIH and NCIB.